using VM endpoints in flows. The Java Virtual Machine, or VM transport, is going to allow us to communicate throughout the JVM. Each app in a Mule instance has its own unique set of VM endpoints, and the VM transport can only handle communications within an app or between apps in the same domain. The transport by default will use an in-memory queue, but you can optionally configure persistent queues. Now, if you are running in a cluster, the VM file persistency is not going to work. Using the VM transport, before Mule 3, the VM transport was used to pass a message to and from flows. As of Mule 3, the flow reference was added to allow the direct reference of messages and sending of messages between flows without having to have a transport in the middle. VM transport is mostly used to achieve higher levels of parallelism in specific stages of processing, allow for more specific tuning of areas within a flow's architecture, such as one-way patterns where you have the dispatcher pool, receiver pool, and processing pool, and call flows in other applications that are in the same domain. Using VMs to tune application performance is covered in Anypoint Platform Development Advanced course, where we specifically look at a clustered use case where we decouple flows by VM queues and allow different nodes in the cluster to take on sections of work. Walkthrough 6.2, pass messages between flows using the Java Virtual Machine transport. We're going to pass messages through an HTTP barrier to get an idea of what it looks like from an HTTP protocol. Then we'll pass messages through flows via VM transports. And then we'll explore variable persistence and get an understanding of what happens with variables when we cross these transport boundaries. In Anypoint Studio, we'll return to the APDev examples project. Let's open up the APDev examples XML if it's not already. Now, let's start off by creating a new global element. We'll do this by going to the Global Elements tab and clicking Create. Once you've clicked Create, let's start off by creating an HTTP request config. So if we type in HTTP, you'll find the HTTP request config in this list. And we'll hit OK. In the request configuration box, let's set our host to localhost, and let's set our port to whatever our inbound port is. In my case, it's 8081. This way I can call my own flows that I'm exposing from another flow via HTTP. We'll then go ahead and hit OK. Now let's return to our message flow view, and let's drag an HTTP connector to the source section of flow 2. So we'll type in HTTP and drag that element to the source area in flow 2. With the HTTP listener selected, we'll make sure our existing HTTP listener config has been chosen. And let's call this flow 2 in the path box. Now, we'll go ahead and add a breakpoint onto the set payload transformer inside of flow 2. Returning back up to our main flow, right after the flow 2 reference, I want to add an HTTP request in. And what we're going to do this time is we're going to access flow 2 via HTTP rather than a flow ref. So we'll delete the flow ref out of the main flow for flow 2, and we'll configure this HTTP requester to call flow 2. To do this, let's make sure our existing HTTP request config is selected, and for the path, let's be sure to put in flow 2. For the method, go ahead and choose get so that we do a get request to the flow 2 path inside of the flow 2. We'll also add a breakpoint to our logger at the very end. Before running this in debug mode, we want to make sure our HTTP requester doesn't time out while it's waiting for us debugging flow 2. So let's select that HTTP requester and go to Modify on the request configuration. What we'll do here is increase the response timeout. By default, it's going to give us approximately 30 seconds. So let's go ahead and put in 100,000 inside of the response timeout box. We'll then hit OK, and let's save the application. If it was already running in debug mode for you, it should restart right now. Otherwise, just go ahead and save and start in debug mode. And once you validated in the console that your app has started again, let's send another request in through Postman. This will be the same request we've been sending all along. And when we go back to Anypoint Studio, what I'd like to do is step through to the HTTP requester with you. So let's go ahead and continue stepping. It should go through subflows just as it always has. And then stop on the HTTP requester with me here. Once on the HTTP requester, we'll notice the payload is still set, our inbound properties seem to still be available, and all of our variables, outbound props, session vars are all present as well. Now, let's step into Flow 2 via HTTP. You'll notice the variables, properties, and session vars are gone. You'll notice that some of the inbound properties have changed, and the QP name has now exposed itself as it should from being a header. If we step forward again and respond back up to the logger, what you'll notice is now the inbound properties have changed because we've gone outbound through HTTP. We've now got an HTTP status from that response, a reason code if applicable, content length and date. If we go into variables, outbound and session vars, you can see our flow vars and session vars are still around since they are attached to the event that's moving through. They don't lose themselves in that original flow. They're going to continue on. And if they go through flow refs, they'll of course continue on as well. The outbound properties, on the other hand, are gone because we've used those as headers in that HTTP outbound request. We can now send the request all the way through, go back to our console, and effectively, we should still see similar details, although the name is null in this case since it's no longer available as that outbound property any longer. Now let's stop the project and see if we can change this paradigm up a bit using the VM transport. In Flow 2, let's delete our inbound HTTP endpoint, and let's replace that with a VM endpoint. We'll drag the VM endpoint to the source where the HTTP listener used to be. We'll select the VM listener, and inside of the exchange pattern, we'll choose request response. Now we can also set the queue path. In this case, let's call it VM flow. And now that we've got this set to VM flow with request response, let's go ahead and replace our HTTP requester with a VM endpoint that will call Flow 2. So we'll select HTTP, we'll drag VM in, and with this VM outbound endpoint, we'll once again say request response. And in the queue path box, let's go ahead and put in VM flow. So this will call outbound or queue up outbound for the VM flow to then receive the message in Flow 2 on the inbound VM flow. Now that our application is set up with VM instead of HTTP, let's once again save it up. And if it's not already running in debug mode, we will debug the project AP dev examples. Once the project has started up successfully, let's go to Postman and make another request. And once your request is in, let's go ahead and step all the way to the VM transport. So once again, we'll move through our subflows just as we always have. Get on top of the VM transport here. And in this case, we're going to send a request into Flow 2 via VM transport rather than HTTP to see how these two transports differ a little bit. So if we go in and do a step into VM, first thing you'll notice with VM is that the session variable did persist. So when sending through VM, it was able to keep that session variable around when going into Flow 2. The outbound properties are no longer there. They were replaced with other items, and variables are no longer there. So flow vars did not cross to Flow 2 with the call that we made from Flow 1. The inbound properties have also changed a little bit, but you will notice that QP name, that header value, was gone across, and it kept itself inside of that inbound scope. Now if we step forward and forward again back to the logger, you'll notice that our inbound properties once again change. Variables, we're back to our original flow variable of QP type. Outbound, no longer there. And our session variable is, of course, still around. Now, one last note on VM transports. You'll find that VM transports are used in specific use cases, oftentimes around clustering and distributing load across nodes. Often, when just sending messages throughout your Mule application, you're going to find yourself using flow references, since they will be quicker and not necessarily have to cross a transport barrier. But as you learn more and more about Mule and get into more advanced architectures and environments, you may find that VM queues are something you leverage in some of your, say, clustered environments. All right, so let's go ahead and stop the application and continue on to the next section.